Algebra 2, set 86, greater than, trichotomy and transitive axioms, and irrational roots. Okay, so the first thing that we're going to talk about is the concept of greater than. It's just a review of how you know something is greater than. It's really easy with the positive numbers, but gets confusing with the negative numbers. So a number is greater than another number if its graph on the number line is to the right of the other one. Pretty simple concept. So if you have -4 and -2, the one that's on the right is bigger than the one that's on the left. So -2 is greater than -4. Okay, so a couple examples. Graph x is less than 3, where your domain is positive integers. So we find 3, and since it's positive integers, it has to be the numbers only, and they have to be positive, so your solution is just 1 and 2. Another example, x is greater than -3, your domain are the real numbers, so x is greater than -3. These should be just really review. Okay, so here are the two axioms. It says for any real numbers a, b, and c. First of all, we're just going to talk about a and b. If you pick any two numbers, you know that either a is going to be smaller than b, or a is going to be equal to b, or a is going to be greater than b. If you pick two numbers, the first one is either going to be bigger than, equal to, or less than the other one. Okay, and then the next thing we talk about is the transitive axiom. If a is bigger than b and b is bigger than c, a has to be bigger than c. If a is smaller than b and b is smaller than c, a has to be smaller than c. And finally, if a and b are equal and b and c are equal, then a and c are equal. Okay, now we're going to talk about this symbol. If you have the symbol where it is crossed out, this is saying x is not less than or equal to -4. So going back to that axiom, if it's not less than and it's not equal to, then it has to be greater than. So we know that x is going to be greater than -4. Our domain is negative integers, so we need all the integers that are bigger than -4. So in this case, it's going to be -3, -2, and -1. Okay, -x plus 4 is not greater than 2. If it's not greater than, then it has to be less than or equal to. So -x plus 4 is less than or equal to 2. We'll subtract 4 from both sides. So we get -x is less than or equal to -2. And then we just graph it. Domain is real numbers. Oh, sorry. Skipped a step there. X is greater than 2. Remember, when you divide by a negative, you have to flip the sign. So we're looking for all numbers greater than 2. So we put an open circle at 2 and go greater than. Okay, graphing this one. We're looking at not greater than or equal to. If it's not greater than or equal to, it has to be less than. We'll solve it, add 4 to both sides. So we get -x is less than 2. Divide both sides by -1 and flip the sign. X is greater than -2. So we're looking for all of the negative integers that are greater than -2. Well, that doesn't give you a whole lot to choose from. Negative integers greater than -2, there's only one. It's -1. Okay, switching gears. Now we're going to talk about irrational roots. So the other day we solved a problem that looked like this, but it worked out nice and neat. Today we're going to work with the ones that don't work out nice and neat. So we're going to solve it the same way. Solve for y. So y equals x plus 1. And then you can either plug y in or square it now and then plug the y squared in. So we'll just square this. And so y squared, x plus 1 squared is going to be x squared plus 2x plus 1. Now we'll take that and plug it in. So we end up with x squared plus 2x plus 1 equals 9. Simplify, 2x squared plus 2x plus 1 equals 9. Subtract 9. Divide everything by 2. And then we try to factor. What multiplies to give you -4 and adds to give you a +1? Well, that is not going to work. Nothing works. It's not factorable. So what do you do? How do you solve a quadratic equation when it's not factorable? You have to go to the quadratic formula. So we write out our equation, and now we'll identify A is 1, B is 1, and C is -4. So remember A, B, and C. Okay, now we're going to use the quadratic formula, which is the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. Now we'll just simplify that. -1 plus or minus 1 plus 16 all over 2. So we get -1 plus or minus the square root of 17 over 2. We're not quite done. So this is just the x's. So now we have to figure out what the y's are going to be. Again, those are your original equations. We know x is either -1 plus square root of 17 over 2 or -1 minus square root of 17 over 2. So I went ahead and split those two up so you can see your two x's. And now we'll plug them in one at a time. The easiest one to plug it in obviously is going to be this one. So plug in your first x, y minus -1/2 plus square root of 17 over 2 equals 1. We'll add that to both sides. So y equals 1 plus -1/2 plus square root of 17 over 2. We can add the 1 and the -1/2 to get 1/2, and then add the square root of 17 over 2. So there's your first y. Now we'll get our second y. To get our second y, we're going to subtract -1/2 minus 17 over 2 equals 1. Add it to both sides. And then put 1 minus 1/2 together, so y equals 1/2 minus square root of 17 over 2. Now I've got lots of jumble on here, so just to make sure, here's the first x and the first y, here's the second x and the second y. And then in order to write it as a solution, we have to write them as ordered pairs. So I'm going to clear out some space here, and there's our first solution, there's our second solution.